All right. So today we talk about polynomials, specifically addition and subtraction. Now, I used to teach this years ago from the perspective of my grandfather, who lent me tools and the importance of putting things back in the right place. But another good way to explain it is laundry. Now, I certainly hope you are young adults. You are anywhere from, I guess, some of you might be 17, but typically 18 through 21 or 2 years of age. And I certainly hope you do your own laundry. Now, when you do your laundry, one of the mistakes that people can make when they first do the laundry, and let's face it, when we do laundry, we want to be as efficient with it as possible. And we want to make our life easier by doing laundry, not more difficult. If we were unlimitedly wealthy, we might go and wear just new clothes every day. But given the fact that I don't think any of us has unlimited wealth, we do our laundry. And then we put it into the machine, and it can be a mess when it goes into the machine. That's okay. We don't care. Though we should sort it. Personally, I have a lot of technical clothing that is designed to wick sweat away from the body. And then I also have, and that's basically stuff that's not cotton. And then I have cotton clothing. So I will break the wash down by technical clothing and then lights and darks that are made out of cotton. When it comes to polynomials, it's kind of like that. And that you just throw it in the machine in any order, it doesn't make a difference. But when it comes out of the machine, we want it to be nice, to be neat, and to be organized. A place for everything in its place. And for that, like you can see in here, it looks like there's shirts, there's jeans, sweaters. There's a whole bunch of different things going into the wash. When it comes out of the wash, you have to organize it so it goes back in the right place. And the reason this is so critically important is because, have you ever been looking for the right piece of clothes? Maybe you're going out on a date, maybe you're going out to dancing, maybe you're going to play sports or whatever, and you can't find the piece of clothing, the piece of attire that you want to find, and you're looking all over for it. You spend so much time looking for that right piece of clothing that you end up taking way more time than if you had just folded your laundry when it came out of the machine. And when you fold your laundry when it comes out of the machine, when you organize it, when you put it in its proper place, it makes life really simple. Another example of when it's very healthy to have things organized is with your money. Now, I don't have a purse, I have a wallet, but I can tell you that in my wallet, my father was a railroad conductor, and he taught me how to manage money. You always put it in order. Say you had $100 bills, 50s, then 20s, then 10s, then 5s, then singles. And the reason you do that is because if you just mix and match, you could accidentally give somebody the wrong bill. So that just emphasizes the importance of having a structure and an organization to what you do. And the same exact thing can be said about polynomials. Now, poly means many, like polytheism is Greek gods. I guess a term that the young people use these days is polyamory, which means you love many people, okay, as opposed to monogamy, which is one. Mono means one, poly means many. Polygamy would be multiple wives, okay. When you see a polynomial, you want to have multiple or many terms going across the front. How many? Two or more many. Okay, so here's a problem that they ask you to simplify. X squared plus 2 plus 6x squared plus 3. And what you're going to do is get all of your x squares together, like when you do your wash, and you put all your wash together, and then you fold your wash so you can put it back in that nice, neat, organized closet. What you're going to do is you're going to get like all your hoodies with your hoodies, your undies with your undies, your jeans with your jeans, your t-shirts with your t-shirts, and so on and so forth. So here, I'm going to get all my x squareds together. So I have 1x squared here, and I have 6x squareds here. Altogether, that makes 7x squareds. And I have 2 and 3. Now, you got to get in the habit here of peeking in front to tell if something's positive or negative. When I look at the 2 and I peek in front, it's a positive 2, it's a positive 3. 2 positives and 3 positives make 5 positives. So the final answer overall is 7x squared plus 5. That is the correct answer. Okay? That's an example of simplifying. So when I'm doing this, I'm looking for variables. Here's a 3x and a 7x, and then constant terms, numbers, a 6 and a 3. If I simplified this, I would get, well, you tell me. If I have 3 x's and 7 more x's, how many x's do I have? I have 10 x's. And if I have 6 and 3, keep in mind it's a positive 6, right? Peaking in front, that's a positive sign. And peaking in front, it's a positive 3. Add them up, 6 and 3 is 9. Some students will say to themselves, oh, wait, so the answer is 10x plus 9. Some students will say to themselves, well, is it a positive sign or is it an addition sign? And the answer is that it really doesn't matter how you look at it. But I have a preference. And my preference is to look at everything in this problem as addition. And the sign in front just tells me whether it's positive or negative. So I'm always adding, and this is no sign in front of 3x means it's positive. So positive 3x's, positive 7x's make positive 10x's. And then positive 6x's and positive 3x's make positive 9. Okay, so here's another simplify example. 2a to the third minus 10ab squared plus 3ab, 3a to the cubed minus ab squared minus 7. So we looked for terms that are the same, and in blue here we have a cubed terms. So if I have 2a cubes, now peek in front, I also have a positive 3a cubes. Altogether that's 5a cubes. Now I have negative 10ab squareds and another negative ab squared. So if I have negative 10 and negative 1, altogether I have negative 11 ab squares. And then I have a minus 7 all by itself, not to be combined with anything else. So my final answer is 5a cubed minus 11ab squared minus 7. And it's important that you realize that you cannot combine an a cubed with an ab squared. Those are totally different things, just as they are each totally different than a negative 7. Okay? And then there's the case where we have a number and then parentheses after it. So when that's the case, we need to distribute that negative 3 to each of the terms in the parentheses. So first I distribute negative 3 times negative 2y makes 6y. Negative 3 times 5 is negative 15. And negative 3 times negative 4xy is 12xy. So I have the original 1 minus 2xy plus 7y plus 6y minus 15 plus 12xy. So then I look for things that are alike. And what I find is, in terms of constants or whole numbers, I have a positive 1, I have a negative 15. Those are all my all my constants. Next, I have negative 2xy's and 12xy's. And finally, I have 7y's and 6y's. So what's negative 1 and negative 15? Positive 1 and negative 15. That's negative 14. What are negative 2xy's and 12xy's? That's 10xy's. And what are 7y's and 6y's? That's 13y's. Now, here's the issue that I want to bring to your attention, and I think this is very important. Some students will think, at the end here that maybe this should be 13y squared, and that's not the case. When you consider combining things, or combining like terms, let me ask you a question. If you have 5 puppy dogs and 4 puppy dogs and you add them up, what do you get? You get 9 puppy dogs. If you have 5 photographs and 4 photographs, what do you get? You get 9 photographs. If you have 5 girlfriends and 4 girlfriends, well, you're crazy. I would go so far as to say you're an idiot, but you would have 9 girlfriends. You don't have enough time in your life, and you don't want any part of that. If you have $7 and $6, you have $15. So if you have 7 Ys and 6 Ys, you have 13 Ys. You do not have 13 Y squareds. And this leads to a universal truth. Whenever you add or subtract anything on the face of the earth, I don't care what it is, whenever you add or subtract it, you always get the same kind of thing that you started with, okay? So that's a really important thing to consider. If you look at the term in blue in the middle here, we have negative 2xy's and 12xy's. That would be 10xy's. No x squared y squares. We're adding up xy's with xy's. Now I know an xy is a weird thing, but it is a thing, and that is what we're adding here. So let's see you try the first two. I'll give you the answers, and then we'll do the last two. So you know what to do. Stop and start. Do the first two. Okay. So in this first one, we have positive 8x's and a negative x. Altogether, that's 7x's. And I have positive 3y's and negative 2y's. That's 1y. So my correct answer is 7x plus y. On the bottom one, 3 n's and 7 n's make 10 n's. Take away 2 n's is 8 n's. And then a positive x and a positive 8x make 9x. So 8n plus 9x. Okay? Try the next two. Okay. So 2 r's and negative 3 r's, that's a negative r. 5 n's and 1 n, that's 6 n's, and 9y. There's my negative r, my negative 4n, and my 9y. Sorry for the delay there. I thought for a second that it was negative. And then for the last one, I have 12y's and 5y's, so that's 17y's. And negative 6x and negative 3x is negative 9x's. You will notice throughout all of these problems two things. The first thing that I want you to notice, or one thing, the first and primary thing I want you to notice is that if I started with x's, I ended with x's. If I started with y's, I ended with y's. If I started with r's, I ended with r's. At no point in time did the exponents change. Very important to understand and to consider. Okay, so here's ones where you have to distribute first and then combine like terms. Go ahead, try numbers 3 and 4. Final thoughts? Okay. So in the first one, distributing the 9, I get negative 54a plus 27 minus 4. And I can combine the constants at the end here. Positive 27, negative 4 make 23. On number 4, I'm going to distribute the 3. 3 times 1 is 3. 3 times 8x is 24x. 3x's and 24x make 27x plus 3. And that's the way you should express the answer. This is kind of hinting at the second thing I said before. We have this thing called standard polynomial order, and we'll do more examples of this, but it basically says you work your way from the highest exponent and amount of variables down. So clearly the 27x term has variables and the 3 does not. So 27x plus 3 would be the normal way that we would express this. And the thing that's so important about that is it's like in the closet. If you're going to find the right clothes and you want to find them instantly so you can go out on that perfect date and have that perfect evening together, or so that you have your uniform for your sporting event, whatever the case, you're going to want that to be your uniform or your clothing to be exactly where you expect it to be. If it's not in the right place where you expect it to be, then you start tearing your room apart and going crazy. And in math, there are places where we expect to find certain things, and if we don't find them there, it often leads to a careless mistake. So you could say, well, that's 3 plus 27x, and you would get credit for that because notice the 27x up here is positive, the 27x on the answer is positive. The 3 is positive, the 3 in the other form is positive. So everything's positive, so it works. So you could always do that check, but typically we want to express it with the variables first, and then the highest exponent on the variables being the first of the variables in the order. Okay, so let's try the next one. Go ahead. We're going to have you just do number 13. We'll do just 13, just 14, and then we'll do 15, 16. So stop and start, do number 13. Okay, so On number 13, I have positive 2x squared and one more x squared. That makes 3x squared. Now, I want you to notice here that it's 3x squared. I started with x squared. I added more x squareds. My answer is x squared. And then here are x's and another x to make a total of 3 x's. So when I combine the x squareds, I had 3 of those, so I get 3x squareds. I have 2 x's and x, so I get 3 x's. What I do not get out of this is 6x to the third. An x squared is different than an x. Totally different thing. Okay? Okay, try number 14. So, remember what I said a minute ago about how you expect to find things at certain places? Well, in number 13, this was a very natural problem. If you didn't feel it as natural as I did, as you do more and more math, it will feel more comfortable for you. The thing that makes it so natural is that the exponent squared, the highest exponent, went right away, where you would expect to find it. In number 14, that's not the case. So I have 5 x's and negative 2 x's. That's a total of 3 x's. And then I have 1x squared and another x squared, which is 2x squared. So if I were doing this, I would have looked for the x squareds first. I said, well, 1x squared and another x squared is 2x squareds. And then 5x's and negative 2x's make 3x's. Now notice, both reasonings are sound, and whether I write 3x plus 2x squared or 2x squared plus 3x, they're equally correct. The advantage to doing 2x squared plus 3x is over time, you will see that the higher exponent goes first, almost always. So then things are where you expect to find them. It's like walking in not only to a nice, neat, organized closet, but knowing where everything in the closet is. Okay, try 15 and 16. Go ahead. Okay. Number 15, 2x squared, because there's only one x squared term, and then the others are all x's. So 3x's and 2x's make 5x's, take away an x makes 4x's. So that's 2x squared, plus 4x's. Next one, there's 2x squared terms. There's a 3x squared minus an x squared, which leaves you with 2x squared, and then 6x's, and the negative x makes 5x's. Keep in mind that 6x is positive because there is no sign in front. Okay? Let's check this guy out. Go ahead. That's not a 9 in front of the parenthesis to distribute it. That's question number 9. Okay, so you'll notice that you want to get your k to the fourths together, then your k squareds together, then your constants together. So I have a negative 4k to the fourth and a negative 3k to the fourth. That would be negative 7k to the fourth. Then I have 3k squareds and a negative 14k squareds. That adds up to negative 11k squareds. And then I have a 14 and a negative 8, and that adds up to 6. So the final answer is negative 7k to the fourth minus 11k squared plus 6. And this is in what we call standard polynomial order, where the exponents are decreasing. It's 4 to 2 to no exponents at all. Okay, try the next one. Okay, so I got x to the fourth first. I have negative 1 and positive 7. I've also, look at this, I've got x to the fifth. That should even go before that. See, that's what I mean about things not being out of, or things being out of order. We should have had the x to the fifths first, and that caused a potential sloppy mistake, though I caught it. 13x to the fifth and 5x to the fifth is 18x to the fifths, and negative 1x to the fourth and 7x to the fourths is 6x to the fourths, and then 6x cubed plus another 6x cubed is 12x to the third. All right. So we call that combining like terms. Again, I like to look at everything as addition. The sign in front just tells me if it's positive or negative. We can also be x to subtract polynomials. Now the big difference here is we have a polynomial in standard form, I like that, in parentheses before the subtract, and another one in parentheses after the subtract, again in standard form. But when I see a negative in between, what I'm going to do is distribute that negative to everything in the parentheses that follows the negative. In other words, what the negative applies to, right? So I'm going to distribute that negative, and what that does is basically changes all the signs. 2x squared becomes negative 2x squared, negative 6x becomes positive 6x, and 12 becomes negative 12. And then I add them up like before. In this example, they stack them vertically. You may appreciate that. I usually do it horizontally. 3x squared and negative 2x squared is 1x squared. Negative 8x and 6x make negative 2x. And 7 and negative 12 make negative 5. So the big reveal here is that if we're going to subtract polynomials, you will see a minus sign and then a parenthesis with the polynomial in that parenthesis. It means that the subtraction applies to the entire polynomial. And the way we're going to handle that is we're going to negate everything in the parenthesis. We're going to distribute that negative sign, negative, negate. It means, negative means to negate or change the sign of everything in there. Here's a comparison between the two. With adding polynomials, which is combining like terms, we don't change anything. It's addition, we keep them the same. With subtraction, it's the same exact question, except the subtraction in the middle. We just change the signs of everything that the subtraction applies to. What does it apply to? We'll know because it's whatever's in the parentheses. And then we do it exactly the same way. So with subtracting polynomials, there's a prior additional step. You've got to change all those signs by distributing the negative. Then you do the same exact thing you have been doing so far in this video. Okay, so let's have you do step by step 3x squared plus 2x minus 5 minus, in parentheses, 5x squared minus 3x plus 2. The first thing I want you to do is distribute that negative sign, change all the signs, and stop. Okay, so this is reminding me to distribute all the negatives. Here's all the signs changed. Look, the positive 5x squared in the original parenthesis is now negative. The negative 3x in the parenthesis is now positive, and the positive 2 in the parenthesis is now negative. So every single sign switched. And now it looks like those questions we started the day off with. And by the way, also want to note the standard order is very, very helpful. X squared X number, X squared X number. So it really helps guide me to find what I'm looking for, like in a nice, clean, organized closet. So what's 3x squared and a negative 5x squared? That's negative 2x squared. What's 2x's and 3x's? That's 5x's. And negative 5 and negative 2 is negative 7. Just so you know, I really don't like having these equal signs here on the left. I think it gets confusing. It kind of looks like it ought to be an equation. Very few people I know ever put equal signs there. They just leave it and write out the work. Okay, let's see you try numbers 5 and 6, and then I'll give you the correct answers. Okay, so for number 5, we're going to first distribute that negative sign, which is going to change the signs. The 4 is going to become negative, and the 2a squared is going to become negative, right? Then I combine like terms. 3a squared and negative 2a squared is 1a squared. 1 and negative 4 is negative 3. Likewise, I'm going to negate the r to the 4th and the negative 5 r to the 3rd. So I'm going to get 4r to the 3rd plus 3r to the 4th. Those are before the subtract symbol. Subtract symbol does not apply to that. And now the r to the 4th gets negated. The 5r to the 3rd gets negated, which means it was negative. It now becomes positive. 3r to the 4th, take away an r to the 4th is 2r to the 4th. And 4r cubed plus 5r cubed is 9r cubed. Okay? Now, it's a little awkward to have the r to the 3rd power before the r to the 4th, so most people would switch the order. That's the commutative property, says you can switch. I want you to notice when you switch the order, this 9r cubed is positive in the beginning form, so in the end form, it has to stay positive. The 2r to the 4th is positive, it has to stay positive. 2r to the 4th plus 9r to the 3rd. Okay, numbers 7 and 8. Go ahead. Okay, for number 7, I have to negate the 5a and the 3, which means 5a plus 4 minus 5a minus 3. 5a and negative 5a, they wipe each other out. There's no a's left. 1 and, 4 and negative 3 make 1. You could have written 0a plus 1. That is technically correct, but 0a means 0 times a, and 0 times anything is 0. So we typically wouldn't write that, but it is equal to it. For the next one, I distribute that negative in the middle to get negative 3x here and positive 3x to the fourth. So 3x to the fourth minus 3x minus another 3x, and then plus 3x to the fourth. 6x to the fourth minus 6x. Notice the order. Highest exponent first. 6x to the fourth minus 6x. Next up. So remember, like eagle focus, super sharp vision, your spidey senses tell you this negative applies to everything after it. So I change all the signs after it, not before. Doesn't apply to what's before, only applies to what's after. So my highest exponent is 5. If I have negative 6n to the fifth plus 8n to the fifth, that's 2n to the fifth. Now I have negative 8n to the fourth plus 6n to the fourth, that's negative 2n to the fourth. And then there's a 9n that doesn't combine with anything else, and a 3. So I get 2n to the fourth minus 2n to the fifth minus 2n to the fourth plus 9n plus 3. Okay? So just a little reminder we spoke of earlier, when you see a number outside the parentheses, first you distribute that number, which we kind of did with that negative sign before. And then we just combine like terms like we know how to do. So if we see a number in front of parentheses, distribute, and then do what we've been doing all lesson. Okay? In this case, 4 times 3x is 12x, 4 times 2 is 8, 2 times x is 2x, 2 times negative 3 is negative 6. 12x's and 2x's make 14x's, 8 and negative 6 make positive 2. And that's a positive 8 peeking in front. All right, let's see you distribute and combine each of those 3 one at a time. Let's try A first. Okay, so I distribute the negative 3 to the x plus 4, and I get negative 3x minus 12, right? Because negative 3 times 4 is negative 12. Plus 5, I can combine the constants here. That's negative 3x minus 7. Because 12 negatives and 5 positives make negative 7. Letter B, go ahead. Okay, so distributing the negative 8, I get negative 16y plus 24, and then I have the minus 6 at the end. I can combine the constants. That's negative 16y plus 18, right? Because 24 and negative 6 make 18. All right, letter C. Distribute both the 3 and the 2, then combine like terms. Go ahead. Okay, distributing the 3, I get 3x plus 12 plus 6x minus 18. And then 3x and 6x's make 9x's, 12 and negative 18 make negative 6. So 9x minus 6 is the correct answer. All right, so now the happy recap for today. First, combining like terms is like doing laundry. You want to gather up your like terms. Like you want to gather up your clothes. Put them all in the machine, get them clean. Then when you take them out, you combine them. You fold them and you put them in piles. Your socks in one pile, your hoodies in a pile, your jeans in a pile, your undies in a pile. What else do we wear? Your hats, whatever, in a pile. Not one big pile of everything. If not the same kind of term, clothes, keep them separate. Okay? So in other words, you don't mix your shirts with your jeans, with your hoodies, with your socks, with your undies, or you will not be able to find things in the right place. If you need to distribute in mathematics, you do that first. If you're going to subtract, distribute the negative sign, which is a -1 and is a form of distributing. And that's that. All right, folks, have a great day.